All right. Can everybody hear me? Excellent, excellent. Thank you all for coming. For those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team at Microsoft, and I'm really super excited to be here again. This is my third year in a row presenting at TechEd New Zealand. Hopefully, maybe some of you caught me last year or the year before. Like last year and the year before, I'm still talking about the same subjects, Exchange 2010. This session will be Exchange 2010 High Availability Concepts. This is the first of 4 sessions I put together for you that will cover both high availability and site resilience. We've got this session, the concept session. Then we've got the deep dive session later on tomorrow, and a couple design sessions, one focused around HA, the other focused around site resilience. And then, of course, I've got one of my tips and tricks sessions for you later in the week as well. Just out of curiosity, a quick show of hands, how many of you are running Exchange 2003? Okay, still got a few hands in there. How many are on 2007? And how many of you folks are on 2010 so far? Great, almost everyone. And how many of you are familiar with what a database availability group is? Excellent, excellent, because that's one concept I assume that everybody here already knows about, so we're not going to spend time talking about that. Instead, though, I do want to discuss a little bit of terminology, just a couple terms that I want to throw at you. So when I say things like high availability and site resilience, everybody in the room understands what I'm talking about. Then we're going to talk about the concept of quorum. We'll talk about the concept of witness, a witness server, and an alternate witness server. We'll talk about active manager. We'll talk about auto database mount dial. We'll also talk about activation preference, and then we'll talk about a couple settings, one for replay lag and one for truncation lag that you can use in your environments, as we'll talk about soon. So let's talk about some terminology. I just have a couple terms I want to make sure everybody understands. Now, we've all heard the term high availability, but the reality is the Exchange team has a little bit different definition than some of the other teams inside of Microsoft. So if you talk to the Active Directory team, or if you talk to the SQL Server folks, or some of the other product groups, they may have a slightly different definition of what constitutes high availability for their product versus what we have in Exchange. An Exchange, in order for a solution to be considered highly available, it has to provide 3 criteria. We have to have service availability, the ability to connect to the database and send and receive messages. We have to have data availability, the availability through redundancy of the data itself. And we have to have one or more mechanisms through which we can get automatic corrective action, what we call failover, by the system in response to most failures. So not every single failure is going to cause automatic recovery, but most failures, things like a disk failure, a server failure, a network failure, and so forth. Some failures are too large for the system to handle automatically. If you lose an entire data center, for example, that's not going to be a failover. Instead, that's going to be a slightly different term called a switchover. So that brings me to the next term I want to define. Starovers, and that's what we use to denote both failovers and switchovers. Now, failover should not be a new term for anybody in this room. Failover is a very old term that, in fact, we usurped from the Windows cluster team. Failover is simply the act of the system manually taking corrective action for you. When an administrator takes corrective action, that's called a switchover. It's a manual act. And that's the 2 types of recoveries you get, a failover or a switchover. It's either going to get corrected automatically by the system, or if it's out of scope for the system, it's going to be a switchover, and the administrator will have to intervene and manually do it. Switchovers, though, aren't always in response to failovers. A switchover could be an activity you perform in getting ready for scheduled maintenance. So switchovers aren't necessarily bad things, although it may require a switchover in some certain failure scenarios. The last term I want to talk about is site resilience. Once again, in Exchange, we have a very specific definition of it. And site resilience, we sort of abstract that into more of a configuration in Exchange than anything else. And it basically refers to the manual process, the manual switchover process. We actually call it a data center switchover. The manual switchover process that you do to activate service and data access in an alternate data center in the event your primary data center can no longer provide whatever required level of service that you have. Okay, so that's it for the terms. Now let's start talking about some of the concepts that are in play. Now, underpinning every single database availability group is a Windows failover cluster. And as a result, we have to deal with this concept of quorum. And quorum is actually a very old concept. It's 15, 16 years old now and in the Windows failover clustering space. And when you go into clustered systems, non-Windows clustered systems that are older than that, the concept of quorum still applies to those as well. So it's a very old term. Yet I find it still confuses some people. And I think part of the reason it confuses people is because we use the term to mean two different things. So quorum is used first as a model of consensus. It's a model of consensus among systems that are connected together so that they can agree on what's happening in the systems. The quorum itself represents a shared view of what's in the cluster. So in this case, in the case of a DAG, there's not a whole lot in the cluster. We're really just talking about the list of DAG members, the nodes that are in that cluster, and some minor resources, a network name resource, an IP address resource, and maybe a witness resource that we'll talk about in a bit. But we also use the term quorum to represent the physical data, the actual cluster database itself that's stored on all of these cluster members. Okay, so it can confuse some people. Now, quorum is important. Quorum is core to the solution because without quorum, not only will you not have cluster functions, but you won't have DAG functions. In order for a DAG member to, for instance, participate in continuous replication, in order for it to mount databases and allow users to access that data, the system has to have quorum. If you don't have quorum, the system comes down. And quorum is simply defined by a majority of the members, or what we sometimes call voters, being able to communicate with each other. So in order to have quorum, you must have a majority of members that are not only active, but they have communications with each other over the network. Now in Exchange, we only use 2 out of the 4 available cluster quorum models. We'll use either a node and file share majority or a node majority. And I'll show you what I mean by that in a second. But quorum is an essential concept to understand because it will impact your design. When you're doing your design, and we'll talk about this later on in some of the design sessions, but for now, just know when you're doing your design, you're designing for resiliency. So the takeaway with the quorum discussion is that the larger the DAG you build, the greater the resilience you have. And that's actually illustrated by this quorum calculation that we have, where the formula for quorum, in other words, the formula we use to determine the number of voters, the number of members we can lose in the solution and still keep the solution up and running, is simply the number of voters divided by 2 plus 1. Okay? We do that, we always add that plus 1 because we always want an odd number of voters. If we have an even number of voters, there's a potential for a tiebreaker, and that would be catastrophic in a cluster. Half the cluster would think one thing, the other half thinks something else, and how do you get the two to reconcile? So there's always a tie-breaking mechanism. There's never going to be a 50-50 split. There will always be, in other words, an odd number of votes that come into play. So as you can see, the number of votes that can be lost depend on the number of votes that are available. Okay, so if you have a 6-member DAG, that's a total of 7 votes. You can lose up to 3 of them. 3 is still the minority, 4 is the majority. As long as you've got 4 out of those 7, the solution will stay up and running. You lose that 4th vote, the entire solution comes down. In contrast, if you look at a 15-member DAG, that now needs 8 votes for quorum. It can lose 7 different servers in that one DAG and still have the entire solution up and running and servicing clients. Okay, so quorum is a very essential concept. So I mentioned we use the 2 quorum models, and this is illustrating them. Up at the top, because we have an odd number of members, we've got 7 members or 7 nodes in our cluster. We already have an odd number, so we can use the node majority quorum model. Now, if we have an even number of members, though, as you see in the bottom where we've got the blue rectangle, by the way, is the DAG. Anything outside the blue rectangle is not in the DAG. So in the bottom one, we only have 6 members in the DAG. We need this external component that we call a witness to give us that extra weighted vote and act as a tiebreaker when it comes time to determine if quorum is available or not. Okay? And of course, as you can see, I've got in the legend there's the quorum database that's represented on each and every single member. You'll notice one of the big differences between the witness server and the DAG members is the DAG members have a copy of the cluster database stored on them locally. The witness server is not a member of the DAG, it's not a member of the cluster, so it does not contain any quorum data. Okay? We'll come back to this picture in a minute, and you'll see how it comes into play. But this basically illustrates the two quorum models that Exchange uses. And what's really cool about it is Exchange will dynamically change the quorum model for you as you add and remove DAG members to and from the DAG. So if I add a server to the DAG, that's going to change the quorum model. It will automatically flip between the two, depending on if I'm going from odd to even or even to odd. If I remove a member of the DAG, it will automatically flip to the other quorum model for you. It's very dynamic, and it's all happening under the covers for you. Again, we'll come back to this. One of the other major things to consider, though, is that unlike the DAG members, the witness server does not vote itself. It's not a member of the cluster, so it can't participate in quorum decisions directly. It cannot vote because it has no quorum data to look at and tell you what it thinks it should be. So the witness server is not a voter. So we'll come back to how the witness server provides that extra vote in a minute. But the key here is that every other DAG member that is a member of the underlying cluster is a true voter, and it carries one single vote. OK, and again, we'll come back to that. We'll also talk about what that file called witness.log is on the witness server, which is a very special file that we use when it comes time for a decision regarding quorum to be made. So I've talked about the witness a little bit. Let's get a little bit deeper into the witness itself. And there's actually a couple terms that are related. So we're going to talk about the witness server, and an alternate witness server. Okay, starting with the witness. The witness is simply a server that is external to the DAG that participates in quorum decisions by providing one of the DAG members with what we call a weighted vote. That's just a fancy way of saying that one of the DAG members in a quorum decision is going to end up with 2 votes instead of 1 vote, as you saw earlier, thereby giving it an extra vote that it can use to maintain quorum if we have enough votes in total. The witness server is configured for all DAGs. Whether you're using an even number or odd number, every single DAG will have a witness server property configured for it because it's a required property on every DAG object that you'll create. So as soon as you create the DAG, you either have to specify a witness server or allow the system to choose one for you automatically. And the system actually only has the capability to choose one type of witness server. When you're creating the DAG, it will look in the current Active Directory site. And if it happens to find an Exchange 2010 hub transport server that does not have the mailbox role installed on it, it will automatically use that as the witness server if you don't specify some alternate witness server to use. Okay? It's that simple. Now, the witness server, although it's configured for all DAGs, it's not going to come into play until your DAG has an even number of members. So a 2-member DAG, a 4-member DAG, 6, 8, 10, all the way on up to 16. Every even number combination will automatically use the witness server. And as I mentioned, it's nothing you need to configure. As you add that 2nd or 4th or 6th server into the DAG, it will automatically start using the node and file share majority quorum model, which will invoke the witness itself. As I mentioned earlier, the witness server, because it's not a member of the DAG and not a member of the cluster, doesn't contain any cluster quorum data. And in fact, it just has really 2 files in a file share is all we're talking about. One we'll talk about in a bit. That's the witness.log file. The other one is one that we just use to periodically verify access to the share and make sure that it's available because we want to make sure that the share is available in case we need it. Now, the witness is part of the core cluster group. So anytime you create any Windows failover cluster, which Exchange is doing for you under the covers, you're going to have a core cluster group. It's actually called cluster group by default. And in that group, normally you would have an IP address resource and a network name resource. And if your DAG or if your cluster is using the node and file share majority, it will also have a file share witness resource. And it's actually the cluster that maintains access and control of that and verifies that it's up and running. Now, the witness itself, as I mentioned, it's just a file share on the server. And in fact, it's represented as a UNC path. So it's whack server name, whack share name. You don't have to create that, although we give you the option to create a specific share and directory if you want to create a custom one. But if you don't have any interest in creating a custom one, which most customers don't, you can go ahead and just let the system use the default naming paths. Now, all of the resources that are needed for the witness are dynamically created and dynamically removed by Exchange as they're needed or no longer needed. Okay, so again, even though we're talking about some of the underlying cluster concepts, you won't actually directly have to deal with them unless you have some sort of catastrophic failure that, for example, affects your entire DAG for whatever reason. Now, because this is a cluster resource, the cluster is responsible for checking whether or not it's available. It uses what we call the isAlive APIs. These are cluster APIs that are, it's kind of a ping on the file share. If it can get to the file share, life is good. It's alive, and I can go on and keep my monitoring going. If it fails that isAlive check, that's when the cluster service takes that automatic corrective action for us. One of the first things it'll try to do is restart it on the node where it thinks it is. If it can't bring that witness resource back online, then it's going to take that entire cluster group and fail it over to another DAG member and try to have it brought online on that other DAG member. Now, if it can't bring it online, it will remain in a failed state. And for those of you who may not be too familiar with the underlying cluster, all cluster resources will have one of three states. It'll either be online, in other words, it's online and operational, life is good. Offline, which it means an administrator took it offline manually, doesn't mean something bad is going on. Maybe they're doing maintenance or whatever reason they manually took it offline. Or it's in a failed state. The server hosting the share went down. The network dropped out between them. For whatever reason, we cannot access that share or that server. It goes into a failed state. It's important to understand these states because it's only when the system detects that the resource is in a failed state, it will try and restart it. If the resource is in an offline state because an administrator took it offline and that resource is needed for quorum, the cluster service will not automatically try to restart it, and an administrator will have to intervene to bring the solution back up. Okay? That shouldn't be too much of a surprise, though, because after all, it is the administrator putting it into an offline mode in the first place. But if it's just a typical resource failure, it's in a failed state, the system will try to restart it. And in fact, it will try to restart it once an hour, every 60 minutes, which may be new behavior if you're used to working with older Windows clusters, Windows 2003 and older perhaps. We didn't have that behavior. This is new behavior inside of Windows 2008. And so you'll want to read that KB that I have up there. That will give you more details if you're not familiar with this behavior. Now, remember, if the witness resource itself is not online, in other words, if it's in a failed state, the cluster will try to restart it. Okay? But it's only going to try once. Either it's able to restart it, in which case quorum will be maintained and the solution will stay up, or it won't be able to restart it, in which case quorum would be lost and the entire solution will come down. So you can start to see how important this concept of quorum is. Now, if the witness, for example, is able to come online, then one of the nodes, typically the node that owns the default cluster group, is going to create a lock, a server message block, an SMB lock, on that witness.log file that I mentioned earlier. And that's important because it prevents the other nodes from establishing a lock as well. Now, whichever node establishes that lock, we call that the locking node. It's easy to remember that term. And all of the other cluster or DAG members that are in communication with the locking node, assuming we have enough of them, they should maintain quorum and that part of the solution will stay up. Any member that's not in communication with the locking node will lose quorum and will terminate its service. Okay, so it's that important. Now, once it's locked, once one of those nodes has that SMB lock on that witness.log file, it owns that file and it increments it. And as I said, all the other members are maintaining quorum through that. And that locking node ends up with what we call a weighted vote. So instead of getting one vote, it now has two votes because it's locked the witness and it's voting on behalf of this extra witness. So that's how we can maintain majority even when we have an even number of members in the DAG because the witness will be there to provide one of those members with that second weighted vote. And of course, once more members come back up and the solution is being restored to full strength, if you will, and the witness is no longer needed, that SMB lock is released just in case another failure happens and we need to lock it again. We release it right away to make it available. We don't have lock contention that way. And then the solution's back up and running and we don't need the witness for quorum again. So going back to this model again, looking at what this looks like, we're just looking at the two different solutions, but in this case, we're only going to focus on the bottom solution because we want to learn what the witness behavior is like. So again, down at the bottom here, I think I've got a laser, we've got a 6-node DAG. Each one of these DAG members has one vote. We've got our witness server over here. It's a file share, and in the file share is this one file called witness.log. So we've got 6 nodes plus the witness. That's a total of 7 votes. Okay, so we lose 1 node. Not a big deal. We don't need the witness. We still have plenty of servers in the DAG to maintain quorum. We lose a 2nd node. Still, again, not a big deal. We've only lost 2 out of 7 here. The solution doesn't need to see if it has quorum. But now we lose a 3rd one. And this is where quorum, the witness, comes into play. Once we lose that 3rd one, that triggers the underlying cluster to go and verify that it still has quorum. And to do that, one of the nodes, as you can see this node right here, became the locking node. It placed an SMB lock on the witness log file, and in doing so, it inherited a 2nd vote. So you can see we still have 1, 2, 3, 4 votes left out of the 7 we need. And as a result, we have a majority, and we still have quorum, and the solution stays up. Okay, now, what happens as we start bringing those failed servers back up? Maybe they were just down for maintenance or whatever. Maybe there were a combination of maintenance plus some failure happened at the same time. We don't know. It doesn't matter. Either way, they're down. Once we bring up the first one, now we have enough servers in the DAG that are up and active. We no longer need the witness to maintain quorum, and we can go ahead and release that lock, and that way the witness.log file is available in case another failure happens. Maybe we go back and another failure happens, and we need to lock it again, and so forth. But once we have enough servers in the solution that are back up, active and communicating with each other, then we no longer need the witness, and the lock is released at that point, even though, again, we still have 2 out of the 3 servers down. Okay? Pretty simple stuff. Now, the witness server. As I mentioned earlier, there's no real pre-configuration that's necessary if you want to go ahead and let the system use an Exchange 2010 Hub Transport server that doesn't have the mailbox role on it. Otherwise, you could go ahead and pre-configure a share, pre-configure a directory if you want, or specify even a non-Exchange 2010 witness server. Maybe you don't have any Hub Transport servers that don't have the mailbox role on it. Or maybe you just have 2 Exchange servers and you want to put both of them in the DAG. And so you don't have any Exchange servers to use at all. You can use any server that you want, and we'll talk about that in a minute. Now, if the server that you use is not an Exchange 2010 server, there is one configuration change that you will need to make. Okay? And to do that, basically what you do is you take the Exchange Trusted Subsystem Universal Security Group, and you add that to the local administrators group on the server you want to be the witness server. The ETS group, the Exchange Trusted Subsystem, it's a special group that gives Exchange all of the permissions and rights that it needs to do things like create the directory on the witness server, share that directory on the witness server, and do everything else related to configuring the witness server. That's really the only configuration element you'll have to deal with. Now, the witness server, as I said, can't be a member of the DAG. Okay? It can be a member of a DAG, but not the DAG for which it's a witness. Okay, so maybe you've got 2 DAGs, and one of the servers in one DAG is a witness for the other DAG, and maybe you've got it vice versa. You could certainly do that. But once you have a witness server configured for a DAG, that witness server cannot be made a member of that DAG ever. We will programmatically block that until you change that. The other caveat, it has to be in the same AD forest. Obviously, we don't have cross-forest permissions going on here, so it does have to be a member of the same forest. Doesn't have to be a member of the same domain. That's a requirement for DAG members only because the underlying Windows failover cluster requires that all members of a cluster be in the same domain. But the witness is not a member of the cluster, so it can be in a different domain provided you've got security set up correctly. It does, however, have to be in the same AD forest. It can't be, for instance, a non-domain joined workstation, if you will. Again, we need to have the Exchange Trusted Subsystem, USG, added to the local admins group. Now, if you decide to use a directory server as the witness server, there is no local admins group. In that case, you're using the built-in administrators group. Now, that is a supported thing, but generally we discourage doing that because at that point, you've taken the Exchange Trusted Subsystem group and you've pretty much made it a domain admin at that point. And depending on your environment, that may not be a desirable thing for you to do. But if that's the only server you have available to act as a witness server, you have no other choice. Go ahead and do that. That's a fully supported configuration. Now, in terms of selecting a server, it can be any Windows Server, Windows 2003 or later. The witness server itself doesn't need high availability. As you saw in the animation, it only comes into play once you've lost a sufficient number of DAG members. So the witness server itself does not need to be made highly available. But let's just say that you have a clustered file server and you want to use that as the witness server. That's OK too, provided that that cluster is running Windows Server 2008. Okay, we need a Windows 2008 cluster for the witness server if you're clustering it. If you're not clustering it, it can be Windows 2003 or later. It's that simple. Now, a single witness server can be used for multiple DAGs. They do all need their own separate directory and their own separate share, and that will happen automatically if you let the system do the configuration for you. If you do custom directories or custom shares, just make sure you use a different directory and file share for each separate DAG. But it's very lightweight use, as you saw in the animation. It only comes into play when we need it, and it's just an SMB lock on one file, so there's almost no I/O, almost no resource use. So you can safely have all your DAGs using a single witness server if you wanted to. Now, I will point out one thing. We do have a code bug. And that is, if you follow all the documentation and you do all the right things, we still slap you on the hand. But that is our mistake, not yours. Basically, what happens is there's a check that we're doing inside, and we're looking to verify if the server that you're using for the witness server is a member of the Exchange Trusted Subsystem group. Okay? And that's not what you want. You don't want the server to be a member of ETS. That makes your witness server basically have all the power that an Exchange server has. That would be a bad thing. You don't want to do that. What you want to do is have ETS be a member of the local admins. In other words, make ETS an administrator on the server. Don't make the server a member of ETS. Unfortunately, in our code, we are checking for that. If you're using an Exchange 2010 server, that server is a member of ETS, so you don't see this error message. But if you're using a non-Exchange 2010 server, that server is not a member of ETS, should never be a member of ETS, but sadly, we check for that. And what's worse, if we find that to be the case, we give you a bad string on top of that. We tell you that, oh, you didn't make ETS a member of the local admins group on the witness server, even though that's probably exactly what you did. So we're working to try to fix that. I have no ETA. I don't have anybody assigned to that bug. It's just a known issue right now. If you're using a non-Exchange 2010 server as your witness server, you're going to run into this. There's no way around it. Just be aware that if everything's working fine, you followed the instructions, you're adding DAG members, and you can see the witnesses working as expected, then you can safely ignore that error. Okay? Again, it's something that we're working on fixing it. If you go to that link, you can read a blog I wrote that explains everything. But basically, it's a harmless error. It's our little mistake. But I want to communicate with folks because it makes the administrator mistakenly believe that they configured something wrong when, in fact, they didn't. Now, there's also this concept and an object, in fact, called an alternate witness server. And this is really a site resilience concept, not an HA concept. But I bring it up because the name alternate witness server does tend to make some administrators mistakenly believe that it's some sort of redundant witness server for your actual witness server. It is not, in fact. The witness servers, a DAG will not dynamically change witness servers. A DAG will only use the witness server that the administrator configured them to use. Okay, and the only time it's going to change to a different witness server is when an administrator makes that change. The alternate witness server is a second witness server that's used by the system when you're doing a data center switchover. Okay, it stems from the fact that in our minds, when you're doing a data center switchover, you are switching from your primary data center to an alternate data center, hence the term alternate witness server. So if you do a data center switchover, part of that exercise involves reconfiguring the DAG to use an alternate witness server instead of a witness server. And you can actually pre-configure it ahead of time. You can use set database availability group and pre-stage the alternate witness server, but the system will not use that until you use one of our site resilience tasks, namely the one called restore database availability group. And we'll talk about that in some of the other sessions as well. But the thing to keep in mind is there's no built-in redundancy for the witness server. The alternate witness server, think of that as a data center switch over witness server. Okay? It's not going to, the DAG is not going to switch to it automatically. It's always a manual reconfiguration to do that. And that always and only happens when you're doing the data center switch over and using these commandlets. Okay, let's talk about Active Manager. Active Manager is probably the most important concept we're going to talk about in this session. Okay? Active Manager is the brain of the high availability platform. It's the brain of the DAG. Now, those of you who've used the DAG, or maybe you've read stuff about the DAG, you know that there's no such thing as a clustered mailbox server anymore. It's gone. Okay? And in fact, if you look in Windows Failover Cluster, you're not going to see any DAG resources. There's no information stored, there's no exchange group, there's no system attendant, there's no databases or storage groups, there's no exchange resources at all. And in fact, you might think of it like this. The cluster has no idea that Exchange is there. In previous versions of Exchange, the cluster certainly knew Exchange was there because Exchange leveraged the cluster resource model. Exchange put cluster-aware resources inside the cluster that the cluster would manage and control and fail over as needed. Now, because there's no more clustered mailbox server, because there's no Exchange resources, the cluster can't help us. If a failure happens, the cluster has nothing to move anywhere. So instead, we had to come up with our own resource manager, our own mechanism by which we could detect failures and take corrective action based on them. That resource manager is what we call Active Manager. Active Manager is not a service. It runs inside a different service called the Microsoft Exchange Replication Service. It runs on not just DAG members, but it also runs on standalone members. It's also now the definitive source of where a database is active and mounted, whether that database is replicated, whether that database exists in a DAG, or whether that database is on a standalone server as well. That is a significant difference over Exchange 2007. Okay, in Exchange 2007, a standalone mailbox server was very different from a clustered mailbox server. In Exchange 2010, there's not that much difference. The only difference is a standalone mailbox server doesn't get to replicate its databases. But a standalone mailbox server, like every DAG member, still has to run the replication service. It still needs the Active Manager component because it's Active Manager and only Active Manager that can decide whether or not a database should be mounted. Okay? We'll talk about this a little bit more. Now, Active Manager, as I said, it runs in the replication service, so it's on every DAG member. And for that matter, it's on every mailbox server, whether it's a member of a DAG or not. And there's also Active Manager client components. There's two. There's one inside the RPC Client Access Service on the Client Access Server itself, and there's one inside the transport stack on Hub Transport Server. These Active Manager clients communicate with the Active Managers running in a DAG so that CAS and Hub know where a database is. And they have to know where a database is because all clients connect through CAS, and it's CAS talking to the mailbox server to get the mailbox data. So CAS has to know where the mailbox is located, and it gets that information from Active Manager. Similarly, Hub has to deliver mail to mailboxes. It has to know where a user's mailbox is located as well. It gets that information from Active Manager as well. For those of you who are developers or ISVs in the room, you're probably used to going to Active Directory to find that information, but we no longer store that information inside of Active Directory. Okay? That means Active Manager is now the only source of where a database is active and mounted. Now, there's three roles. We're only really concerned with two of them inside of a DAG, but for full disclosure, there are three roles. The standalone Active Manager role, that's on every mailbox server that exists before it's put into a DAG. And then once a mailbox server is a member of a DAG, it's going to have one of two roles. It's either going to have the primary Active Manager role, the PAM, or the standby Active Manager role, the SAM. Okay? And we'll say PAM and SAM from now on because primary Active Manager is a mouthful. So PAM and SAM. Now, in every DAG, there will always and only be one PAM. Okay? And we make it easy. It's the PAM role is held by whichever DAG member happens to own the default cluster group. So as that cluster group might move from node to node, so does the PAM role. Every other member that's not the PAM holds the SAM role. Now, the PAM role is the one that's responsible for all the heavy lifting. It monitors things. It takes corrective action. The SAM role is there to monitor things, but it can't really fix things on its own. It has to talk to the PAM, and then the PAM goes and fixes things for it. But the SAM, though, does have a secondary purpose. It's also there to respond to the Active Manager client that's running on CAS and Hub, so it can tell CAS and Hub which server it needs to talk to in the DAG to deliver mail or to connect that client up to their mailbox. Now, the PAM, as I mentioned, that runs on the default cluster group. So whichever node owns that and that group can move around, that node is the primary Active Manager. Okay. And that'll do things like look at the list of servers and get topology notifications and find out, are things moved around? Did a mailbox get moved? Did a database become active somewhere else? It's also responsible for reacting to server failures, although that is one case where we do get some information from the cluster. Once one of the DAG members drops off the network, it's actually the underlying cluster that will tell Active Manager about that, and then Active Manager will go and take the corrective action. Take all those active databases that were on that failed server and move them over, fail them over, if you will, to one or more surviving DAG members. Now, Active Manager has a very specific process that we call best copy selection. Best copy selection is the process that it uses to determine which database copy, if you've got multiple copies of a database, is the best possible copy to activate. Okay? Now, the activation might be the result of a failure, or it might be what we call a targetless switchover. Remember, switchover is an administrator manually moving the database somewhere else. The administrator has the option of doing what we call a targetless switchover. In other words, the administrator can say, switch over this database, but Exchange, or Active Manager, you pick the best copy. I'm not going to tell you what server to switch over to. I certainly have that option. I can specify a server, but I also can say, system, you figure it out for me, choose the best copy, and just switch it over. That's what we call a targetless switchover. So Active Manager's best copy selection will be responsible for choosing that best copy when you have a failover or when you do a targetless switchover. And then, of course, if something goes wrong with the local information store or local database, it will detect those failures right away as well, because all Active Manager instances monitor their local store and local database instances. Now, the SAM, as I mentioned, that's on every other node of the DAG. So any node that doesn't own that default cluster group, any node that's not the PAM is automatically the SAM. And it does similar things. It'll monitor its local store. It'll monitor its local databases. It'll monitor for server failures. But it can't react to any of those. Okay? It can't do anything on its own. Only the PAM can take the actual corrective action. So what SAM does is SAM notifies the PAM, and then the PAM takes that corrective action. And it doesn't matter where the failure is, that corrective action, in other words, a database failover, or if it's an entire server, a server failover, that's going to happen at the database level within 30 seconds or less. Very, very fast failover. If you do a switchover, it's probably going to happen even faster. Now, both roles, SAM and PAM, are necessary for automatic recovery. And in fact, because they run in the replication service, it's actually the Microsoft Exchange replication service that's required for it. Now, obviously, if that service isn't running, you're not going to have continuous replication going. But if that service isn't running, you're also not going to have databases mounting on that server. You're not going to have any failovers or switchovers happening on that server. And that server is simply not going to participate in DAG or cluster functions. Okay, so it's important that that service be monitored and that you have a very high level of uptime on that service. Okay, now let's talk about the concept of auto database mount dial. How many of you are running CCR in Exchange 2007? Okay, just a few hands. Because auto database mount dial is not a new concept in 2010. We actually introduced the concept in 2007, although we changed it a little bit in 2010, and I'll show you how we changed it in a second there. But just a quick question for you. When you've got a replicated mailbox database that's affected by a failure, what are the two types? How did I draw that? What two types of recovery are possible? Just raise your hand if you think you know. What are the two types of recovery that's possible? I'll give everybody a hint. We talked about it in the terminology section. Two types of recovery, either manual or automatic. Okay, either the system can automatically fix it for you or it can't, and you've got to do it manually. Okay, how does that work? Exchange 2010 uses the auto database mount dial setting as part of the automatic recovery logic. How many of you are familiar with this setting? Now, let me ask you a different question. How many of you are running a DAG again? Raise your hand if you're running a DAG. Okay, now keep your hand up if you're familiar with this setting. Okay, that's a little worrisome. Everybody running a DAG, and for that matter, those of you running CCR still, you desperately want to be aware of this because this is the dial. This dial doesn't actually look like this, but this is a nice illustration. This dial determines whether or not Exchange can automatically recover based on a failure or if it's going to require administrator intervention, and the dial is simply based on the number of log files that didn't make it over to the copy being activated. In other words, the number of missing log files on the passive copy. Now, if I go back one slide, you can see this dial is configured using the set mailbox server commandlet. Many of you may have ignored it completely because we have it set by default to what we call good availability. And in fact, I'll go ahead and to the next slide and show you what the options are. So good availability, that's the default. That means 6 or fewer log files are missing from this passive copy. If we go to activate a passive copy and we look and it's missing 6 or fewer log files, that's okay, we will still mount it. If it's missing 7 and it's set to good availability, we will not mount that. We'll try another database if it's available, and if it's not available, it will be up to the administrator to intervene and manually take corrective action at that point. Now, there's other settings. Best availability, 12 logs lost. You can kind of see how the naming comes into play. Good availability, we're referring to the availability of the data. The whole idea behind the dial is that it's an administrator's way of saying, I am willing to tolerate a little bit of data loss, this much based on my dial setting, and still allow that database to be mounted. Okay, now in 2007, we used this, plus we also used the lost log resilience feature that we had. That lost log resilience feature was the linchpin back then because for the first time, it enabled an Exchange database to be mounted with missing log files. And when we say missing, we're talking about missing at the end of the log stream. We still can't mount any databases if you have gaps in your log stream. But if you're just missing the last few log files, and they're beyond the log files that are required for the database to mount, we will still mount it. Of course, what's in the logs? It's data, so that would refer to missing data, or what we call a lossy failover. In other words, there's been some data loss. But we typically don't worry too much about the data loss because of the other feature inside Hub Transport called the Transport Dumpster, which will recover about 95 to 99% of the data that would be lost by those missing log files. The rest of the data it can't get back is easily recoverable by users repeating actions. Accepting a medium request a second time, or marking something read or unread a second time, and so forth. But it's the missing log files that controls whether or not the system will mount the database. Now, there's other settings. You can set it to lossless. That's 0. That's your way of saying to the system, if there are any logs missing, do not mount this database. I will only mount this database if the failover or switchover is lossless. Now, all switchovers generally are going to be lossless unless you're doing a hard force switchover because you've lost data and you just have to force a database to come online. But generally, most switchovers are going to be lossless. It's the lossy failovers you want to control with this dial. Now, there's also best effort. Best effort doesn't come into play for failures. Best effort comes into play for switchovers. You can actually override it and say best effort, meaning it's unbounded. It doesn't matter how many logs I've lost, just mount this database with whatever you've got. Of course, use that at your own risk. You could be mounting a database with 1,000, 10,000, 100,000 missing log files. It's a lot of data. Each one of those log files is a megabyte of data. So that could be a lot of data loss. But in a catastrophe, if that's all you have is this one database copy that's maybe behind the times, it's missing a bunch of log files, a few hundred maybe, 1,000 or whatever, this is all we have, you're going to use best effort to force that online and mount that database. So you've got most of your data being recoverable and accessible by the users. Now, we also support a custom value, but you can't set custom values using set mailbox server. Set mailbox server only allows you to use best availability, good availability, or lossless. If you want to do a custom setting, you're going into ADSI edit and actually modifying the parameter itself. Typically, we recommend doing that by a factor of 6 or 12, but you're free to choose any number that you want. Just be aware, though, if you start going beyond 12 log files, you're going to also want to correspondingly increase the size of the transport dumpster so that it can hold more data in there for you. Okay? If you don't increase the size of the transport dumpster and you go to a custom value that's quite large, you've seriously opened the potential to lose a bunch of data there. So always increase your transport dumpster accordingly when you're using a custom value there. Okay. So, how does it come into play? When Active Manager goes through its best copy selection, and we'll talk about that in the deep dive. I don't want to get too deep on Active Manager. But when it goes through its best copy selection process, that's when we consult the dial. So one of the processes inside of BCS, inside of best copy selection, is a sub-process called attempt copy last logs, ACL for short, ACLL. And what that does is if I've got a failure of my active database and I'm activating this passive one over here, as part of that activation process, Active Manager goes back to the original active database and tries to copy over any log files that are missing by this passive copy it wants to activate. Maybe it'll be successful, maybe it won't be. That's simply going to be based on the nature of the failure. If the disk containing the database and the log files went away, it's not going to be successful. There's going to be log files that could not be copied over. Obviously, if Active Manager is able to copy all the logs over, it's not going to be a problem. There won't be any missing log files, and even if you're set to lossless, the database will still mount. But we try to copy the log files over, and if that doesn't work, we stop that process, and then we look at the auto database mount dial. And we say, is the number of missing log files within that dial threshold? If it's within the dial threshold, we'll mount the database automatically. If it's not within the dial threshold, if it's outside the threshold, the database will not be mounted, and we'll either try another copy if one's available, or we will fail, and we will alert the administrator that they have to intervene and manually mount this database because we could not mount it because it was outside the auto database mount dial threshold. So, how many of you feel comfortable with your understanding of that setting now? Not everybody. Okay, well, maybe for those of you who want more, we'll talk about it more in the deep dive, and then, of course, I'm here all week for questions, too. But you will want to understand this because the actual setting you use, particularly if you're running 2010 Service Pack 1, the actual setting you use will dictate to a certain extent how that best copy selection process works and whether or not databases will mount, as I said. Remember, the two forms of recovery, automatic and manual, the automatic recovery is completely predicated on your auto database mount dial setting. So you will want to get familiar with that setting. As I mentioned, the default is good availability, so if you haven't touched it, that's what yours is set to, and as I mentioned earlier, that's 6 or fewer logs lost. Okay, now let's talk about activation preference. How many of you have heard of this term? Okay, just a few of you. Okay, this is a new term in 2010. It didn't exist in previous version. Activation preference, and this can be a little bit confusing, in part, I think, because of the terminology we chose. I think using the term activation preference may have misled people into thinking that it's doing a little more than what it actually does. So what it is, it's basically a whole number that's assigned to every database copy. So if I've got an active copy and 3 passive copies, in other words, 4 copies of a database, each one of those has a unique number, 1, 2, 3, or 4. Okay? The activation preference value cannot be greater than the number of database copies that you have. In other words, the number of copies of a single database. Okay? And as I said, it's just a whole number where, in this case, the lower the number, the higher the preference it gets. Okay? So if it's got a preference of 1, that takes precedence over something that has a preference of 2. Now, how we use this bit differs based on whether you're running RTM or SP1. In RTM, it's basically used as a tiebreaker. when we go through best copy selection, we sort the list of available copies to choose from based on the copy queue length, based on the number of log files that haven't been copied from the active to the passive. Okay? Again, going back to that auto database mount dial. And obviously, the ones with the lower copy queue lengths, those are more up to date, so they're higher in the list. But if we have two copies of the same database that, for whatever reason, happen to have the same copy queue length, in RTM, we will then use activation preference as a tiebreaker. Okay? And in that case, the one with the lower activation preference shows up in the list first. Now, in SP1, it has a slightly different meaning. In SP1, we took it a step further and said that if you set the auto database mount dial to lossless on all of the servers that have a copy of the database, then instead of initially sorting by copy queue length, we will actually sort potential passive copies by activation preference. So it will have the meaning that most administrators think it has based on the name we gave it, but that will only come into play with SP1 when all servers hosting a copy of it are set to lossless. And I've got, again, in the deep dive session, when we get into BCS in more detail, I've got some great animation that will demonstrate this for you. But basically, those are the two different ways we use activation preference in RTM and SP1. In SP1, if you're not set to lossless on all the servers, we use the RTM behavior. So, simple example, very, very simple example, multiple copies of a database in multiple data centers. I've got one DAG extended to 2 data centers, and I've got 4 servers, and in this case, 4 copies of my, this one database I've called out. So I've got the active copy here, the passive copy on 3 other servers. Okay? Activation preference, as I said, is nothing more than a number assigned to that database copy. Now, I happen to randomly assign 1, 2, 3, 4 this way. The administrator can change those numbers around. If they want to make the passive copy in data center 1 with an activation preference of 4, they can do that. If they want to make a passive copy in data center 2, an activation preference of 2, they can do that. If you don't do anything, the system makes it for you. As soon as you create your first database, that has an activation preference of 1. As soon as you make the first copy of that database, so now you've got 2 copies of a database, the second one will automatically get an activation preference of 2. The third one you create gets 3. The fourth one gets 4, and so forth. But again, you can change those numbers around. But if you don't manipulate the numbers, the activation preference will pretty much be the order in which you created your database copies of that particular database. Okay? Again, very simple concept. We'll see that in more detail as it all comes together in the deep dive when we go deeply into the best copy selection process. But for now, just be aware that activation preference is simply a numeric property that you put on all copies of a database based on, in this case, your preferred order of activation. Because that's how you can think of it, whether we're sorting it by copy queue length and using it as a tiebreaker, or whether you're sorting it by activation preference directly because you've got a lossless setting for your auto database mount dial. Now, activation preference is not a guarantee. Even if we sort the list, the nature of the failures and potential fears basically make it impossible for us to guarantee that activation preference can be used. For instance, you might have a database that's inside the same data center as you saw before. If we go back here, you might say, well, you know, anytime a failure happens here, it's always going to activate here because that's the next activation preference. There's no guarantee. Okay? The failure might be both of these servers went down, but these 2 stayed up, and the witness stayed up, and the network is still here so that they can communicate with the witness. And so the ones with the activation preferences of 1 and 2 simply aren't available. So that means 3 and 4 could be activated, but that's going to be based on, again, copy queue length and auto database mount dial. Okay? Now, you can reconfigure this on the fly. Okay, you can use set mailbox database copy to do that. You can go inside the Exchange Management Console and simply change the number on the database copy itself. Every copy exposes its properties in the EMC, and you can go ahead and change that. Doesn't require any restarts. It dynamically takes effect the moment that you change it. And as I said, the number is simply not going to be larger than the number of copies that you have. So you saw in the example where I had 4 copies, the largest number I could do was 4. 1, 2, 3, or 4. Now, we also use activation preference as part of what we call DAG rebalancing. And basically, rebalancing a DAG means making all of the DAG members equal with respect to the number of active databases they have, the number of passive databases they have, and the sum total of the activation preference values of those databases. In fact, we have a script that we ship called redistribute active databases that will rebalance the DAG for you. We'll talk about rebalancing the DAG in another session as well, but we do use activation preference as part of that balancing mechanism. Okay, and the last thing I want to talk about in this session are replay lag and truncation lag. Again, we introduced these in 2007 and carried them forward into 2010. I'll talk about replay lag first because that is the much more commonly used setting. A replay lag time is simply when you've configured a mailbox database copy with a replay lag time greater than 0. Okay? We first introduced replay lag time when we introduced standby continuous replication in Exchange 2007 Service Pack 1. We did have this hard-coded lag of 50 log files that we kept, but we also allowed the administrator to add additional lag time on top of it. And basically, that was the administrator's way of preserving a point-in-time copy of the database. In other words, we copy the log files over and we inspect them and we put them in the final resting place, but we don't replay them until the timer for the replay lag time runs out. And at that point, that's when we replay them. So it keeps this copy far behind in time than your other copies. And in fact, we have a special term for it. We call it a lagged copy. We don't call it a highly available copy. Okay? Any database copy that has a replay lag time greater than 0 is a lagged copy, not a highly available copy. It's a special copy. It's a copy that should be blocked from automatic activation. If you allow the system to automatically activate a lagged copy, it will replay all outstanding log files and destroy the lagged nature of the copy. Activation of a lagged copy is always a manual process. It always involves first taking a copy of the database and its logs and preserving the lag nature of them and then activating that copy somewhere else. Okay? Now, it's always configured using set mailbox database copy, and you can configure it at any time. Doesn't have to be configured at the moment you create the database, like we did in Exchange 2007, where once you were adding that standby copy, at that point you had to set the replay lag time. You can now do it dynamically on the fly, and it will take effect right away. Lag copies are really only for point-in-time protection. Some customers use them as a replacement for backups, but some customers don't because lag copies only go back 14 days. That is the maximum lag time you can set on a lag copy. Okay, so if you need to go back in time with your database copies greater than 14 days, you're probably going to need some other mechanism, and that's typically a traditional VSS type backup. Now, lag copies are there really for scenarios like logical corruption. Okay, physical corruption the system handles for you. In a physical corruption case, we do rigorous inspection of every single log file that goes to every copy. And we do that independently. The inspection we do on one copy is completely isolated and separate from the inspection we do on all the other copies. If we detect that there's physical corruption in that log file, we will actually re-request that log file. We'll do that up to 3 times. If we can't get a good log file after 3 times, we will halt replication and prevent that physical corruption from getting into your copies. Logical corruption is different, though. Logical corruption is typically something created by an application, whereas physical corruption is typically something created by a bad controller or bad hardware. Logical corruption doesn't really manifest itself to the system because all the bits are good. It's really the equivalent of a 0 changing to a 1 or a 1 changing to a 0. It's still valid data, but when an end user sees it, there's something not quite right with it. This calendar item won't stay on my appointment. Somebody has to keep sending it to me. Or this mail message that I got won't stay marked as read. I mark it as read, and it shows up as unread again. Those types of things are logical corruption. You'll know it when you see it because it almost always involves a third-party application. Yes, there is the potential for Exchange to cause logical corruption, but in my career, I've not seen that. I've only seen logical corruption caused by third-party applications integrating inside of Exchange. So when you are deciding whether or not to use a lag copy to protect you against logical corruption, you simply need to look at your own history. You have to see what sort of third-party applications you're using, and do I have any history with logical corruption? You might have very well-behaved third-party products, and you might never have experienced logical corruption, and therefore you might feel that you don't necessarily need to be protected by it by using a lagged copy, and you might use some other mechanism or just leave yourself open to that vulnerability if you don't see it as a large risk. If, however, you have a lot of integrated applications, and more importantly, if you have a history of logical corruption in your environment, then you're probably going to want to use a lag copy or some other backup or some point-in-time mechanism so that you can go back. Logical corruption, unlike physical corruption, can't really be detected inside the continuous replication stream, and so it will make its way to the other copies. So, when should you deploy a lag copy? That's typically the question that gets asked. It's really there when you need to mitigate the risk, when you think you have a risk of logical corruption infecting one of your databases. Now, it might not be needed if you're deploying a backup solution, and I say might because arguably a lag copy, because it's online, it might be behind in time, it's online though, and it's already accessible by the system, arguably you might be able to activate a lag copy more quickly than you can activate a backup copy. In fact, if you're really good at detecting the corruption and you act quickly and you've got an online lag copy, you could probably get activation going probably before people could even find the right backup tape that they needed to do the actual restoration. So even if you are taking backups, you still might find using a lag copy advantageous. But of course, again, lag copies are not HA copies. It's nothing the system should ever activate for you. You're going to block activation on any copy that you make a lag copy. So that will prevent Active Manager from using it during BCS. Okay? Otherwise, if the system automatically activates it, it will destroy the lag nature and you lose your point-in-time backup. So you don't want to do that. One of the other things that you want to keep in mind is we have this new feature inside Exchange 2010 called ESE Single Page Restore. Okay? Or sometimes we refer to it in blogs and in documentation as page patching. Okay? We have this page patching feature in there so that Exchange can actually repair itself after it encounters a bad block on disk. You may be aware that certainly while we still support RAID, and there are some scenarios in which we strongly recommend RAID, there are also scenarios in which we say you don't necessarily need to use RAID. You can use what we call JBOD, just a bunch of disks. Okay? That's actually not new. JBOD is what we had before we had RAID, so it's very, very old. It's disks that are unprotected with a RAID mechanism. Now, RAID is very good in that it protects you from bad things happening on a disk, like bad blocks. Once a RAID controller scans a disk, all the bad blocks are marked, and that controller will never write data there. But if you're not using RAID, if you're using JBOD, JBOD doesn't do that for you. So that means there's the potential for us to write bad data on one of those bad blocks, or good data on a bad block, rather, and have that data be lost in what we call a lost flush scenario. What we can do, though, in a replicated environment is we can actually get that bad page from a replicated copy because we've got the data in a replicated log stream. So we can literally ask one of the other copies for a good copy of the bad page, and we can patch that page up and then internally keep a record of the bad block and not rewrite to it. So we have that mechanism that normally is provided by RAID built into Exchange. But it only works for HA copies. It does not work for lag copies. Again, the data's in the log stream, and a lag copy holds back that log stream. We have to wait for the log stream to get replayed into the database so that we have a database page we can use to repair, for instance, a bad block on the active copy using this single page restore mechanism. So we've got a great mechanism in there for protecting HA copies on JBOD, but if you're using lag copies, your lag copy is probably not going to be on JBOD. You're probably going to be using RAID for your lag copy, unless you're using multiple lag copies, which you may or may not want to do based on your actual failure scenarios that you want to protect. But keep that in mind. If the lag database has page corruption in it, that page corruption is going to stick in there. And basically, it's going to destroy the lag nature of the copy as well. So in that case, you're going to want to use RAID or multiple lag copies. Now, we also have this other lag setting. This is called truncation lag time. So whereas the replay lag delays the replaying of the log files on the passive copy, truncation lag time delays the truncation of replayed log files on a passive copy based on whatever setting you set it to, again, up to a maximum of 14 days. So you can kind of see how the replay lag time comes in because it gives you that point-in-time backup. You might be thinking, why do I want to keep the logs around on a passive copy for? Why wouldn't I just truncate them when I'm done with them and not let it build up? Well, the reason is the truncation lag time is there to give you the ability to recover from the loss of logs on the active copy. Okay, remember, all logs are generated on the active copy and replicated to passive copies. If you have some sort of failure affecting the log stream on the active copy, and now you've got the active copy fails and goes down, and the passive copy is activated, becomes the new active copy, and you want to go ahead and get that active copy back up as quickly as possible, if it's only missing log files, you can copy those log files over from the passive copy that has a truncation lag time greater than 0. Provided you're in that same time window, but you can still get those log files from the passive copy. Without the truncation lag, those log files would be truncated once all copies agree to the truncation, and they wouldn't be available for you to recover, and the only recovery mechanism you'd have available to you would be reseeding that copy. Okay, and that could be expensive. If you have a database that's, a terabyte, 2 terabytes in size, you probably want to avoid reseeding as much as possible. And so a truncation lag can help you do that. And again, just like the replay lag time, that's configured using set mailbox database copy, and there's nothing to reset or anything. It just happens on the fly. Be aware, though, that using either of these settings will have implications for your storage design. Obviously, if there's a replay lag time, log files are building up on the passive copy. Okay, they're not getting replayed, and therefore they're not getting truncated, and so you need to account for that extra storage. Similarly, with a truncation lag time, log files are sitting around on a passive copy for much longer than they should be, or much longer than they would normally be. And as a result, you need the extra storage space to account for that log growth as well. So keep that in mind. Plan your storage design accordingly when you're using these features because they will directly impact storage vis-a-vis your capacity. And again, check out that TechNet article because we go into depth about how these affect you. Okay, so that's it for the concept session. We have the deep dive, the 2 design sessions, one that's going to focus on in-data center high availability, the other is going to focus on site resilience and so forth. And then I've got an Exchange 2010 tips and tricks and SP2 session coming up as well. You'll also, I know many of you also are using Link as well, so you also want to do the load balancing sessions and the high availability sessions for Link as well. And with that, I think I may have like 1 minute or so for questions, and I'm happy to take those. And here's some resources for you as well, the Exchange Team blog, my blog. You can also follow me on Twitter if you want, where as soon as anything happens, we post a new blog, we post a download, we discover something noteworthy. I'm one of the first people on the Exchange Team to tweet it, so if you follow my tweets, you'll get things as soon as they happen. And some other resources for you, and then, of course, don't forget to fill out your surveys. So with that, I'm happy to take any questions that you guys might have. Just go ahead and raise your hand if you have one. Yes, sir?
Many of those sessions will be going into DAC?
Yes, in the deep dive and the design session, we're going to be talking about DAC mode, Data Center Activation Coordination Mode. That's the site resilience thing, so I didn't really include it in the HA portion of it, but that's a great question. And I'm glad you know that term. All right, well, thank you all for coming, and I hope to see you